Hello everyone. In this video we are going to see Gauss Seidel method. Okay, so earlier in the last video we have seen Gauss elimination method. So this is Gauss Seidel method. The purpose is it is an iterative technique used to solve a system of linear equations the way we did for Gauss elimination. Okay, so what is the system of linear equation? It is of the form Ax equal to b, where A is the square matrix which consists of the coefficients of the unknown variables. Then X is the column vector of unknowns and B is the column vector of constants. Okay, we will show what does it mean. So how do you solve it? So first we choose an initial value guess for x0, that is x1, x, y and z. We will make some initial guess and then we will iterate using the update formula until the solution converges. And when the convergence take place, when the error between the new value and the old value is not much, that is the difference between the two values is less than the tolerance value. When it becomes less than the tolerance value, we will stop. This tolerance value we can decide. Okay, so this is the system of linear equations. So as I have mentioned, Ax equal to b. So what will be the values in a11, a12 up to a1n, then these a21, a till this part. So these a values will be a square matrix and it will be present in capital A. Okay, then what will be present in this x? In this case, x1, x2 up to xn. And in case of b, all these are vectors. Okay, b1, b2, bn, all these values will be present. Now coming to, we will try to solve one example using mathematical example using Gauss Seidel method. So you see, this is the system of equations. So first of all, we need to rewrite this equations in this form. So x1 will be, that is for this equation, we will keep x1 in the left hand side and the remaining things in the left hand side. So this is what we got. Similarly, for second equation, x2 will be in the left hand side and then other things in the right hand side. Similarly, third equation we will express in terms of x3. So these are the first thing is to do like this. Okay, now we are going to choose some initial guess. So in this case we are choosing x1, x2 and x3 value as 0. Okay, so in the first iteration, we will consider this as equation 1. So here we will put the values of x2 and x3 and x3 as 0. So what we got? 2.7. Then in this equation we are going to put the new value of x1. We got 2.7, right? So new value of x1 will be put here and x3 will be still 0. So we got x2 value, this one. In the third equation, that is this equation, we will put the new values here. So we got this answer. So what are the new values? 2.7, 8.05 and minus 6.05. Now we will see the difference between x1. Let us consider this as x1, x1 1 and x1 0 and x1 x2 1 and x2 0. So we will see the difference between the new value and the original value and we will select some tolerance value. So if the difference is less than that, then we will think that these are our new values, new roots. Otherwise we will keep on continuing these iterations till these values become less than the tolerance value. Okay, so here you see we have gone for second iteration. Here again we have put the new values, that is whatever we got here, no, 2.7, 8.05. using these we have put it in the same equations again we got these new values. So we will keep on continuing till the difference between the old and new values become less than the tolerance value. Okay, so let's write the C++ program. So first of all, we will include the header files. Okay, so what are the header files? Hash include iostream and hash includes cmat. Okay, so now we will see this part later on. So using namespace std, then after that we are going to write down the main part. So in main, so here we are calling the function Gauss Seidel. So when we call the function Gauss Seidel, where we will go? We will go here, void Gauss Seidel. The return type is 0 and no arguments. So this is the function. It will start from here and it is going to end here. So let's see what is written inside it. So first of all, we will take a variable n. Here we are giving the value 3 because the number of equations is 3. If you see this, suppose this is the system of equation that we are going to solve. So there are 3 equations. So that's why the value of n we are giving as 3. Then the A matrix, that is the square matrix. What it is, it is having 3 rows and 3 columns. If you see this, 3 rows and 3 columns. What are the values? 10, minus 3, 1, 2, x, 1, and minus 1, 2, and 5. So that's what we have written here. 10, 2, minus 1, first equation, second equation values, and third equation values. Okay, so it is a 3 by 3 matrix. And then apart from that, the B values we are taking. What are the B values? If we see the equations, 27 minus 61.5 and minus 21.5. So these are the values we are taking, the constants. And then the unknowns. How many unknowns? x1, x2, x3. So initial value for these we have assumed it to be 0, 0, 0. And the tolerance value we have kept it as 0.0001. And how many iterations we will be doing? Say we will be doing 100. You can change it. Okay, so these are the initial declarations that we have made. Okay, so let's see. So from this point onwards, the iterations will start. So when int iter equal to 1, that is we are going into the first iteration. Okay, so we will enter the first iteration. Here float x old is equal to x0, 1, x1 and x2. So what are the values it is going to store in x old? X0. X0 means what? Is if you go up, x0, if we go up, we have used these values, right? Let me see. Yes, this 0, 0, 0, right? So here initially we will have 0, 0, 0. These are the values stored in x old. Now we are going to enter the loop here. So I will explain how it is done, this particular loop. Okay, now we will be playing with the loops. So here we are going to enter the loop here. Okay, I'll just write down here I equal to 0. So what is the current value of I? Now 0. Now 0 is less than, n is the number of equations, 0 is less than 3. 3 equations, so it is less than 3. So it is true. So we are going to enter. It means that we are going to enter the loop from here to here. It means that we are in equation number 1. Now if we are in equation number 1, what should be the if we see here, let me check where it was. Gauss Seidel method, right? Okay, so if we see this equation, what should be the value of x1? 27 minus initial value we have chosen 0, 0. So ultimately we should get 27 divided by 10. That is this equation expressed in terms of x1. We should get 27 by 10. So we will try to get that with the help of the coding. So here we are going to, since it is less, we are going to enter the loop. And what we are going to store in sum? In sum, the value of sum is equal to b of I. B of I means I value is 0. I value is here, it is 0, less than 0. Okay, I value is 0. So b of 0. What is b of 0? If you see, b of 0 is 27. So what is present in 27? Sum, it is 27. Now for j equal to 0, so now we are coming here. Now j is equal to 0. Now 0 is less than 3. True. So we are going to enter the loop. Now here you see, but here if you see the condition, j is not equal, if j is not equal to I, then only you are going to proceed. But if you see here, I value and j value are equal, so we are not going to enter perform this step. We will directly increment the value of j. Now what is the new value of j? J is equal to 1. Again 1 is less than 3, so we are going to enter the loop. So here again if we see, now this time j is, it is 1, I is 0, so it is not equal. So we are going to enter, come here. So here what we are going to do, we will change the value of sum. Sum is equal to how much? Sum, what is sum? We got here, no, 27. 27 minus, sum minus equal to written a of ij. A of ij means I value is 0, j value is 1. A of 0, 1. what value is present in A of 0, 1? If you see, this was our matrix. Suppose A of 0, 1 means this is row 0, 1, 2. 2 is present, right? So here we are going to put in the code 2, but ultimately x of 0. So x of 0 will be how much? Initial value of j is equal to into 0 only, right? Because I, j, here everything x value we are having 0. Here we have already added 0 here, no? X value all 0. So ultimately what is the sum? Sum value remains 27 only. It will remain 27 only. Again, if we increment the value of j, now it will become 2. Again 2 is less than 3. Again we will enter. But this time also, even if we see, sum will be equal to sum minus a of ij. Ij means I is still 0, 0, 2. 0, 2 means, if we see, 0, 2 means this value. This value, that is minus 1. Okay? Minus 1 into minus 1. Here it will be sum equal to, again sum we will write, sum equal to, sum is 27 minus 1 into minus 1 into x of 2. X of 2 is again all the values are 0, so 0. So ultimately this sum value remains 27 only. Then again j value will increment to 3, right? Here it will become 3. Now 3 is less than 3, so we will come out of the loop. So ultimately what is the value of sum? We got it as 27 only. Then here what we are putting? X of 0. So x of 0 will be what? That is the first item, right? That is the first value. So x of 0 is equal to sum. Sum remain 27 divided by a of 0, 0. I value is 0. So a of 0, 0 is what? If you see, a of 0, 0 is 10. So we will write down 10 here. So ultimately you got 2.7. This is what we need to get, right? If you see this one also, if you see the equation also, this is exactly what we should get, 27 by 10, because these two values are 0. So this is what is happening for equation 1. Okay, this is what is happening for equation 1 after the end of this one. Now we will increment, obviously. Okay, now we will go for the second loop. So now this time we will increment the value of I. Okay, so what will be the new value? That is, we are going for equation number 2 now. We have started with 0. Now it is 1. 1 is less than 3. So we are entering the loop. Float sum equal to b of j. So what is b? Sum is equal to b of I. What is the value of I? 1. So what is b of 1? If you see, b of 1 is minus 61.5. Minus 61.5. Okay. Ultimately, if you see what is our purpose for the second equation, if we see here, we need to calculate this part. This is what we are trying to do using the formula, using the loops. Okay. So some value is clear. Now we will start with this part. So now we are going to start here. So j is equal to 0. 0 is less than 3. So we are going to enter the loop. So here we will check if this is true or not. Now obviously j is not equal to I. So we are going to change the value of sum. What we are going to do? Sum equal to sum. What is the value of sum? Minus 61.5. Then minus a of ij. So what is a of ij? That is a of 1, 0. So what is 1, 0? Row number 1, 0 minus 3. So here we are going to put minus 3 into what? X of j. X of j means x of 0. So in the previous equation, x of 1 we got some value, right? 2.7 we got. So we will put it like that. So after that, this is done. Then again we are going to increment the value of j. So now what is the new value of j? Now j is equal to 1. Now 1 is less than 3. So again we are going to enter this loop. Okay, now we will increment the value of j now. So j has become 1. As I have told, it is 1 less than 3. So we are entering the loop. Now if j is not equal to I, then only we are going to do but here j and I value are same, so we are going to skip this one, and again we are going to increment the value of j. So now j is equal to 2. Now 2 is less than 3, so we are going to enter the loop. Okay, so when we enter the loop, so this time what will happen? 2 is not equal to 1, so we are going to change this one. So obviously in the previous step, after performing this, you will get some value, no? Let it be 77. I'm just assuming it to be 77. This is the previous loop. Okay, so now this time again we will change the value. Now sum is equal to what? Sum. So what is the value of sum? 77. So I'll just write down 77 minus a of ij. A of ij means a of 1 2. A of 1 2 means row 1 column 2. So 2 minus 2 into what you will write? Xj, x of 2. So what is x of 2? X of 2 is, in the previous step you got the value, x of j. X of j means x of 2. Yes, x of 2, what you got in the previous step, if you see x of 2. So if you see this one, x of 2 is 0 1 2, it is 0. So you will write down 0. Ultimately, what is the value you got? 77, right? So finally, sum value is 77. Now you will increment the value of j again. Now it will become 3. 3 is not less than 3. So you will come out of the loop. So here x of I is equal to sum divided by a So here what you will get, what it is? X of I. X of I means x of 2. Sorry, x of 1. X of 1 is equal to sum. What is the value of sum you got? 77 divided by a of I means 1 1. A of 1 1 means which value? A of 1 1 means this value, minus 6. So ultimately you will get some value. Let us write it as 95. Okay. So we have implemented this equation properly. So here for this equation we have minus 61.5 plus 3 into the x1 value that we got from the previous loop, and this x3 value is 0 as of now. So ultimately we got the values of x2. So in the first, when the first j loop ran, the value we got for x1, when it ran for the second time, we got the value of x2. Okay, now let's go back to the program and see. Okay, I'm talking about this particular loop. Okay, so 2 times it has run. So now after this point, the value of I will increment again. Now it will become, it was earlier 1, now it will become 2. Okay, 2 is less than 3, so we will enter the loop. So what we are going to put in sum? In sum we are going to put b of I, that is b of 2. So what is b of 2 here? If you see, b of 2 is minus 21.5. So here we will put minus 21.5. Okay. Now again we are going to start the loop from here. So now here we will start from j equal to 0 again. J equal to 0, 0 less than 3. So we are going to enter the loop. Now here again, j value is 0, I value is 2. It is not equal, so we are going to enter the loop. So here what we are going to do? Sum equal to sum. So what is the value of sum now? Minus 21.5. This minus a of ij. So what will be the value of a of ij? A of 20. What is a of 20? 1, right? 1 into j, the x of j. J value is 0. What is x of 0? The value that we got when we ran this loop for the first time. So it was, I think, 2.7, right? So this will give some value. So let us assume that it is equal to something, say 55. Okay, just for now you assume it. Then again you are going to increment the value of j again. So now j is equal to 1. 1 is less than 3. So it is going to enter the loop again. Then it will check, j is 1, I is 2. This is not equal. So again we are going to enter the loop. So this time what is going to do? Sum is equal to sum minus. So what is the updated value of sum? 55. So it will be 55 minus a of ij. A of ij means a of 2 1. What is a of 2 1? 1. So this into x of j. X of j means 1. What was x of 1? The value that we got in the previous loop. I forgot the value. Let's assume that it was 87, say. So here we will calculate it and we will get another value. Say we are getting 83. Okay, just assume. So now the value of sum is 83. Now again you increment the value of j. So j value was 1. Now it will become 2. So 2 is less than 3. So again it will enter the loop. Now you see 2 is not equal to, it is false because they are equal. So we are not going to update this one and we are going to go to this one. So x of 2. So what will be x of 2? X of 2 will be equal to sum. What is the sum value we are getting? 83 divided by a of 2 2. What is a of 2 2? If we see what is a of 2 2. A of 2 2 is 5. So divided by 5. So here again we will get some value. Say I am telling you 76. Just assume it's not 76 or 13. Just assume it. So this is the value of x2. So finally we got value of x1, x2 and x3. Then again we are going to increment the value of j, right? So j will become 3. Now 3 is not equal to 3. So we will end this loop and we will increment the value of I. Now I will become what? 3. 3 is less than 3? No. So we will stop this loop also. Finally we are going to come out of this loop and then we are going to come to this part. Okay, now we are going to check, that is how many times this iterations, we are still in iteration number 1, right? So how many times we are going to do the iteration? If we will check, if fabs means absolute value of x of 0. X of 0 is 1. These values we got no just now, x0, x1, x2. X of 0 minus x old. X old is what? If you see here, x old is, here we have written, right? Yeah, x old is 0 0 0. Initialized we have taken the values, no, 0 0 0. So whatever value we got minus x old, that is the value of the previous, when we entered the loop, the old value. If this is less than the tolerance value, we will give some tolerance value. In this case I think we have given the tolerance value as 0.001. So if it is less than tolerance value for all the individual levels, that is x0, x1 and x2, okay, if it is true, then we will say that that is we are going to stop the iteration and we are going to come out of the loop. And if not, we will keep on continuing the loop. After coming out of the loop, we will come here. So the final solution, that is the when the value of x is this much, the x of I is this. That is where at cout x I plus 1, that is in the iteration 1, what is the x of 1? X of, initially we will write down x of 1 is equal to this, x2 equal to this, x3 equal to this. 3 values, right? 3 equations, 3 unknowns. So x1 equal to this, x2 equal to x of it will be 1, x3 equal to x of 2. Why y plus 1 we are given? Because we don't write x0, right? We write x1, but the value will be of x0. So finally, so this is the whole program. Now let's see how we see the output. Okay, so whatever I had written extra things I have omitted here. So we are going to run this particular program. So let's compile and run. So Gauss Seidel iteration process. So the solution is x1 is equal to this, x2 equal to this, and x3 equal to this. These are the values of x1, x2, and x3 when we have this as the square matrix, b values this much, tolerance this one, and number of iterations 100. Okay. So that's all for today's video. Thank you everyone.